Okay, so I want to formally welcome everyone here to my talk today. We're talking about applying change data capture at scale. It's good to have everyone here, so let's just get to it. First, I'll do an intro. I wrote a bit of stuff here, but I'll just quickly read it so that we can have a clear idea of who I am and my background. So, my name is Julian, maybe Duru. I'm a software engineer and architect at MoneyPoint. I also happen to be an amateur cyclist and swimmer. Also, sometimes delve in drone photography. So, I've been a part of the engineering team at MoneyPoint from its inception, and I've been involved in numerous products, including POS monitoring, virtual accounts, and most recently, business loans. So MoneyPoint plans to give loans to businesses, and I was a part of the team that worked on that product to be able to deliver loans to our businesses. So I am constantly tinkering with technology of different forms in order to stay abreast of latest trends in software engineering and development. Whenever I'm not writing code, I really love to cycle. I also love to play video games, and I love to hang out with friends. And I also love to engage in a number of different hobbies. So, once again, welcome to my talk. The talk is about change data capture. Let's go over the table of contents, some of the things you should expect in this talk. First thing I'll talk about is what is change data capture. Then I'll also discuss why and when to use change data capture. Then I'll talk about the forms of change data capture, the different forms. There are different forms of change data capture, as we will see in my slides. Then we'll do a deep dive into a log-based change data capture in practice. Then we'll also look at some popular CDC tools. And then I'll give you a demo where we'll look at some of the things that I have set up as regards to change data capture. And then finally, we'll look at some trade-offs and when not to use change data capture. All right, so what is change data capture? Now, change data capture, or CDC as you can call it, is a technique that allows you to track changes that happen in a data source and utilize those changes in downstream processes or systems. So you are able to respond to events in several ways. It could be as simple as updating another database, or it could be as complex as triggering entire workflows in an event-driven system. What do I mean by all this? Let's say you look at this diagram here. In your typical database, you have changes that are happening at the database level. It could be an insert or an update or a delete. These are all changes that result in changes in your application state. And with change data capture, you want to be able to capture these changes as they are happening and utilize them in other services or processes. It could be you want to utilize it in another database, or you want to utilize it in a cache, or in a data lake, or in a search index. For example, the changes that you capture via change data capture can allow you to update a cache or to invalidate cache entries, as the case may be. You could also use it to replicate data into a data lake or to update a search index, as the case may be. So why do we need change data capture? Why and when do we use change data capture? First example I'll give is if you're doing real-time response to change events at the database layer as they happen. So sometimes you may want to be able to handle events at the database layer in real time as they are happening. And that's one example of when you want to use change data capture. Also, in some cases, you may want to do some form of system-wide data synchronization and replication. So let's say changes have happened in one form, one part of your system, and you want to be able to replicate those changes in other parts of your system, or at best synchronize those changes in other parts of your system. Then you can make use of change data capture. Then if you're building or if you're working with some form of event-driven architecture, in an event-driven architecture, you're concerned with events and responding to these events as they happen. So when events happen, these events could be in the form of changes at the database level. So when you capture these changes, you can propagate them as events in your event-driven architecture. And that's another example of when to use CDC. In some cases, you may want to trigger entire workflows from a stored procedure that's just executed, or a database event or database job. So that's another example of when you could use CDC. What about extending legacy systems? Let's say you have a system that is like an old or legacy system. It has its API and database all set up. And then you don't want to modify that system, but you want to add some extended behavior to that legacy system, such that as changes are happening to the database of that system, you want to be able to trigger other events or other workflows. So that's another example of when you can use CDC. You can use it to extend legacy systems. And the final point I mentioned there is for audit trailing. Let's say you're tracking changes to your data source as they are happening. You can use CDC to capture these changes and use these changes in whatever way you so desire. All right, so what are the forms of change data capture? What are the forms? What are the forms? The first one I mentioned here is timestamp-based change data capture. Now, in a timestamp-based change data capture, you have systems that will query the source based on a timestamp. So source items with a timestamp that is above the threshold will be read for change updates. If you look at this diagram here, there are two database systems. One of them is a source, the other is a target. Now, the target, you have some kind of timer. The timer is what allows you to keep track of when next to issue a timestamp-based query to the source. So what happens is, at regular intervals, this target system can issue a timestamp-based query to the source to fetch all the changes that have happened since the last timestamp I read. So those changes will be read from the source to the target. Now, this is perhaps one of my least favorites, if not my least favorite approach to change data capture. And the reason for that is because at some point, this target can become a burden on the source database. Remember, you are issuing a query from the target to the source. So imagine you have an API that is sitting on top of this source database. The API is serving users, and you have a lot of load that is coming to the source database. So a lot of entries are being written to this source database. Now, if you have a target system that is issuing timestamp-based queries, that target system can become a burden on this source DB, because at regular intervals, the timestamp-based queries are going to run against the source database. Sorry, there's some prayer happening in the background, so I hope you'll be able to hear me. Okay, let me continue. So you also have trigger-based CDC. Now, trigger-based CDC uses database triggers. These are simply special procedures that are automatically executed or triggered when certain changes happen to your database. Now, if you look at this, you have a source database and a target database, like I said. And in your source database, you are depending on triggers. Triggers are supposed to execute at the source level every time there's a change at the source. So these triggers could be stored procedures, or it could be database events, or whatever it is you set up. But the idea is that when these triggers are run, they push these changes that have happened at the source to the target. So this is kind of better than the timestamp-based queries, but I also have issue with trigger-based CDC, because in your trigger-based CDC, your triggers can also serve as a kind of bottleneck. So assuming now you have a lot of load on the source database, your triggers can add some extra overhead, because your trigger is a piece of code that is meant to run. anytime a change happens at the source database, the trigger is a piece of code. So that piece of code can add up over time, or particularly if you have a lot of load on your system. If you have a lot of load on your source system and you are executing a trigger for each of the entries that are happening, those triggers can add up exponentially, and then you have some bottleneck at your database level. But the idea behind trigger-based CDC is that you have triggers that are able to automatically execute when certain changes happen at the source, and they can push changes to the target database. Okay, and then let's move on to log-based CDC, which happens to be my favorite and most often the recommended approach, depending on what you're trying to accomplish. So in log-based CDC, you are basically tailing the change log file of your data source, and you're looking for specific entries in the logs in order to apply those at a target system. So if you look at the diagram that I have here, already today, database systems have the concept of a transaction log. In case of MySQL, you have a bin log. Postgres, for example, has a write-ahead log. Essentially, these are logs that are able to keep track of every change that has happened at the database, and it's essentially just a log file. So what happens is you have a connector or a service that is able to read through these log files and look for specific entries in those logs. When those entries are found, then the changes can be effected at the target database. Why is this preferred to the other two I mentioned? Because this approach is very unobtrusive. Unobtrusive in the sense that it doesn't intrude on your existing system. It doesn't disturb your current system. Your current system already has the concept of transaction logging. It's able to log transactions at the database level. So what you're doing is just to connect something to be able to read those logs and effect changes at a target database. I hope we're following so far. I'm doing a lot of talking and I'm not getting feedback, but I hope that we are all following what I'm explaining and it's making sense so far. Can I get an amen in the comment sections if you are with me? Hello? I just want to be sure that people are with me. Thank you so much. Thank you. All right. Thank you, guys. So we've gone through the different methods of change data capture. So far, so good. This log-based CDC, let's do a deeper dive into what it really looks like. So there are different examples of log-based CDC, different examples of log-based CDC tools, but we want to look at the Debezium, which is one of the most popular. And the way it works is that it's tracking changes in your data source and updating Kafka. Kafka is a messaging queue. So as these changes are happening, let's look at this full diagram. You have an API on top of your data source, right? This API is serving users, serving clients, serving whoever. And as changes are happening, the logs are being written to your transaction log file. MySQL has what's called a bin log, where every entry, as long as you enable transaction logging for MySQL, every change that happens in that database will be written to the bin log. In the case of Postgres, it has a write-ahead log. So changes are written to the write-ahead log first before they are effected on the database. So what happens is the Debezium reads these change logs and then updates Kafka. So you will see Kafka entries at the topic, at a specific topic. And then from those Kafka messages, you now have different systems that can plug into Kafka and can basically handle the change updates however they please. If you want a database to replicate those changes, you can have such a setup. If you want a cache that can maybe cache those changes or invalidate certain entries in itself based on the changes that are happening, you can have that. If you want a search index, if you want a data lake, all of them can plug in as consumers to Kafka and respond accordingly. So what are some popular tools in change data capture? We have Debezium, we have Kafka Connect, we have Oracle Golden Gate, we have Talend, IBM Infosphere. There's a bunch of others, but of all these, the ones I've worked with are mostly Debezium and Kafka Connect. I have worked with Talent, but that was a long time ago. I don't think I still remember how to use it. But most likely, if you are trying to do anything related to CDC stuff, most of what you will see is the popular tools, and much of the popular tools are Debezium, Kafka Connect, and so those are the very, very popular ones. In this demo, or in the demo that we'll do, I will be showing you how to work with a library that works with Debezium. All right, so let's just do a quick demo and see some of what I'm talking about. Now, I have a test that is running here. There's this library I built. I'll share the link to the library so you can look at it later. But I'm hoping you can see my screen. So I have this test I'm currently running. It uses a Docker Compose. The Docker Compose spins up a bunch of services, including Zookeeper, then Kafka. Then we have AKHQ. Let me just quickly describe the services. Zookeeper is for orchestrating and managing our Kafka cluster and for synchronization. Kafka is basically, of course, our messaging queuing system. More recent versions of Kafka are trying to move away from relying on Zookeeper for orchestration. So they are based on more on different protocols like Raft and so on. So that for now, let's just work with this. Then we have AKHQ. AKHQ will allow us to view what's happening in Kafka, and we can see the different topics, the messages in those topics, and so on. Then we have the database that we'll be reading from and database that we'll be modifying to be able to look at these change updates. And then finally, we have, okay, not yet finally, we have Postgres. Postgres is another database which we're running. So we're running two databases in our setup, MySQL and Postgres, right? And then we now have our Debezium connector, which is another service which is running. So we have all these services currently running in my local environment, and we're going to look at how they can interact with each other. But first off, I want to demo, there are two primary things I want to demo. One of them is data replication. The other one is change data handling. So in the case of data replication, that is, changes are happening in one database and we are replicating them to another database. So that's why I have two databases set up, MySQL and Postgres. So in my test, what I configured, if you look at this application, the YML file, I hope this is clear enough for you to see. You have source connector. Please let me know if you can't see my screen, because I'm hoping that this is clear enough for you to see. We have two connectors. We have a source connector and a sync connector, right? The source connector is connected to my SQL database, right? As you can see, these are the credentials and the parameters for MySQL, including the database I'm interested in and the table that I'm interested in, right? And then the sync connector is connected to the Postgres. So the test is currently running. If you come to dbeaver is a database client. This is the Postgres database, right? And so let me show you, if I do a query on MySQL database, this is what, right? And then let me do the same thing for Postgres. If I refer. So what I want to do, I want to insert a bunch of entries in the SQL database. Zoom in a bit. Okay, is this? I'm hoping this is clearer. Someone asked me to zoom in. Let me zoom in again. I don't know. The zoom in is not working. Let me zoom. But I was able to zoom in here though, so you can see the queries I'm running, right? So what I want to do is I want to insert. Hold on. I want to insert into the MySQL database, right? So I was able to run an insert. If I do a select, you can see that over here in the MySQL database, the data has been inserted. Now this is the Postgres database. Immediately I inserted in MySQL, it was replicated to Postgres, as you can see. Let me insert another entry into the database. This is my brother's name I'm inserting, so Ebi. I want to insert again so you can watch it. So I inserted another entry into the MySQL database. Let's run a select query. If you run select, you can see Ebi's name is here, right? Let's go to Postgres, and then you'll see that it was also replicated there. Now, what kind of magic is going on? What exactly is going on? Let's slow down a bit and understand. Now, I want to go to AKHQ, which is our Kafka viewer. AKHQ will allow us to view or see what exactly is happening behind the scenes, right? Remember, we spun up a bunch of services, including 2 databases, right? And if you look at AKHQ, there's a topic that is created here, which is for our change updates as they are happening. So let me open this topic so you can look at what's going on here. These are all the messages that are arriving in the topic. I'll click on this last one so you see. The messages that come in contain both the schema and the payload. This is the payload, that's the schema and the payload, but I'll expand on the payload. So you can see that the entry that I inserted in the database, this is it here. These are the items here. Is this big enough? Can you see? I hope you all can see. The entries that are inserted in the database, as you can see, it came to my Kafka topic, and you can see the entries. The entries are here. This is the last one that I inserted. This is my brother's name. So you can see the payload has different sections, right? There's the before section, which is null because there was nothing there before. Then there was after, which is after the change happened, right? After the change happened, these were the items that were inserted: the name, the address, the gender. You also have the source of the change, which will include the database name, the row, the position, the database, the table as well. And then this OP stands for the operation. So operation has a value of C. C for create, meaning that the entry was created, right? You can expand on another entry in the Kafka topic. So you can see that this is the second entry that I inserted, right? This was the second entry that was inserted. Similar to the other one. Okay, so let's go back. I want to insert one more entry, right? I'm going to insert my sister's name here, Kemchor, but I will intentionally leave the gender as male, M, because I want to use it to demo something else later. So let's insert this. And of course, if I run my select query on both databases, right, you see that the data was replicated accordingly. This is the second database. So imagine you're running a database per microservice architecture where each of your microservices has like a different database, right? And as changes are happening in one database, you want to somehow replicate or transform those changes into another database. You can accomplish that using very minimal code, using this kind of setup I've just shown you, where you have a source and a sink, and then basically as data is inserted at the source, you're able to replicate it at the sink level. All right, so that is all for replication. Now let's go into change handling or change processing. For that, I will show you 2 change processors that I coded myself. Let me release my breakpoints. So we have 2 change processors that I coded myself, right? One of them is a create handler. The other one is an update handler. Let's look at the code for the 2 of them. I hope you can see this code clearly. I tried to expand it, but let me see. View, can I zoom in? Is there a zoom in somewhere here? I'm not sure I can't find a zoom in. But let me just assume you can see what's happening here. So if you notice, there is a change consumer. This class is annotated with a change consumer, right? And it declares a source ID. The source is the employee user table, which we have been playing with, right? And the change type is create. As you can see, this is create. So what that means is every time a user is created, right, I want to process it. The process method is the one that handles all the logic for processing that change update. If you look to this other side, this is an update processor, right? It declares something similar to the other one, but instead the change type now is update. If you look here, what I have here is update, meaning anytime a user's details are updated, I want to process that change. So we're going to demo both of these handlers and see how they work. So the first thing I'm going to do is I'm going to insert another entry in my database. So let's go back to this DB. I'm going to insert another entry, Soma Duru. It's my whole family that I want to insert in the database today. Anyways, let's just insert. So immediately I inserted it. So you can zoom. Okay, Control Alt S. Someone said Control Alt. No, this is search for zoom. Change font size, zoom with Control mouse wheel. Okay. It's not working. It's not working in IntelliJ. I don't know. I thought I knew it, but let me just continue so I don't hold the demo. So let me just, so you can see immediately I inserted that entry, it hit my breakpoint, yeah? And you will see that the data was immediately inserted the data came to my processor immediately, right? So the data that I inserted in my DB, immediately the change happened. I can see the name here, Soma Duru, the address, and then the gender. The operation that was carried out was create, right? So this is different from a replication scenario. In this scenario, I want to implement some logic at the code level whenever a change happens at the database. View menu, let me see, view menu. Guys are trying to, okay, so presentation mode. Where is presentation mode? Presentation mode. Where is the presentation mode? I don't know. I'm Shalva. I don't know where the presentation mode is. But can you guys see my IntelliJ? Like, can you see view, appearance, zoom in? If someone can figure out how to zoom in on IntelliJ, just let me know. I've not had this problem before, so I don't delay.
So
view appearance.
Yeah, view appearance, enter presentation mode is an option. Yeah.
Oh, okay. Okay, but is this? Oh, I see. Yeah, but I mean, I wanted to show you what I was debugging. Okay, maybe I can. If you look at this payload that arrived here now. Okay, nice. Good one. Okay, so if you look at the payload, after I inserted it, you can see all those entries I inserted came in here, right? As you can see. So I can now go ahead and handle the code however I wish. I want to go out of presentation mode now. I want to play my breakpoints. So to leave the presentation mode, let's see, exit presentation mode. Debug. Yeah, so let's just play this, right? We see that I'm returning an operation status success, which means that I've successfully handled that event. So I play it, right? That's gone. But what has just happened is that I inserted an entry in the database. I think I might have inserted twice. I inserted an entry in the database, right? And I was able to handle it at the database, at the application level, right? So what this pattern does is that you can create consumers, you can build up applications that are loosely coupled consumers that are responding to changes in application states. Let's look at the update processor now, right? So if you remember, I inserted my sister's name with a male gender, right? So let's change that to female, right? Let's change it to F for female. And then I save it. Yeah, so immediately I saved it. See, it came to my update handler. Let's enter presentation mode, appearance, enter presentation mode, right? So let's look at the payload that arrived here. Let's see the payload. If you look at the payload that came here, the payload will have two sections, right? Before and after, right? Before, we can see that the person my sister had a gender of M for male. But after I made the change, my sister had a gender F for female. So this was an update that happened at the database level. It didn't pass through an API. It wasn't an API that triggered this. This was just an update that happened at the database level. But because it was written to Kafka by the connector, and I've basically plugged in a consumer to that connector, to those connector topics, right? I'm able to read these changes and respond to them at the application level. So you can see I have both what the data was before and what it was after, right? It came in my update processor, and I can handle it however I wish. If you look at my code, what I'm doing here is I'm returning a failure 3 times before I now return a success. If you return a failure, the engine that I've built, that I coded, basically what to do is to keep retrying your handler until it gets a success response from you. So let me just play this, and then we'll see return failure. Let's remove these breakpoints. So it's going to hit the failure 3 times before going to success. And then once it returns success, that's it. It's not going to try to call it again. So I hope, does this make sense? Guys, are you with me? I hope this made sense so far. So I'm not getting any comments in the section. Okay. Good show. All right. So let me continue with my. Oh, I just wanted to give the demo so you see what it looks like. If you want to look a bit more on the library that I built, which I used to accomplish some of this, this is the link to the library. I included a README. I think. Let me just drop it here. I also included a README so that you can follow some of what's going. It's written in Java. I code mostly in Java, but I also do TypeScript as well. Okay, so let's now see what are some of the practical applications of CDC at MoneyPoint. So if you know, MoneyPoint processes a lot of data. We do so much data across our different services, right? And so we need to sometimes be able to warehouse this data for archiving purposes or for different purposes. So CDC allows us to accomplish that. When changes happen in one data source, we can easily replicate it to a data lake somewhere or another data source without having to write much code to accomplish that, right? So that is where CDC comes into play. Data warehousing, data replication. Also, in our core banking transaction alert system, when transactions happen and they are consummated at the database level, we're able to write these updates to a Kafka topic, and then interested consumers can plug into this Kafka topic and read or process these topics however they wish to do so. All right. So what are some of the trade-offs, and when should you not use CDC? People who are experienced in software engineering and architecture will always be the first to tell you this. Just because something can be done doesn't mean it should be done. There are always trade-offs to consider in software architecture. There are pros and cons for every software architecture. Sometimes there's no correct right answer, and sometimes you arrive at the right answer through iteration. But when should we not CDC? First, if tracking every data change is overkill, then you may not want to use CDC, because what you are doing with CDC is that for every change that is happening, you are going to want to track it and probably process it in one way or the other. In some use cases, that is appropriate, but in some use cases, that might be overkill, and you may not want to do that, right? Also, be mindful of your Kafka bill. Remember, for each of these changes that is happening, we are writing a message to Kafka. So be mindful, because your Kafka bill can blow up if you are logging all your database changes to Kafka. Unless you absolutely need to do that, you should avoid doing that. Also, you might risk exposing sensitive information. Remember, you are logging changes that are happening in a data source to a Kafka topic, and you may not want some clients to be able to see that topic. So be very mindful when you are doing something like that. Also, if your workload is more read heavy than write heavy, remember you are interested in change updates. Changes happen when you are writing. So if more of what you are doing in your workload is reading as opposed to writing, then that might be an issue because or you might not need to do CDC in such a case, or you may not need it as much in such a case. CDC is most appropriate for write heavy workloads. All right. So that being said, I'll leave on this final note. Change is good. So embrace change today. I put a very weird smiley face there just so anyways. So thank you all for this presentation. You can follow me on my socials. Instagram is no, I'm not very active on Instagram, so I don't really send updates that much. But on Twitter, Twitter is like a public diary for me. So I use Twitter like to just post my thoughts and write about all kinds of stuff on Twitter. LinkedIn is also there, Julian Duru, on my email, durutheguru@gmail.com. Duru the Guru was a nickname that I had in secondary school, so it just kind of stuck. But yeah, so thank you all. Thank you all for the demo and the presentation.
Thank you so much, Julian.
How are you, my guy?
Very happy to have you. So before you go, we have a question from
Okay.
Sharp. So he said, it sounds like these CDC techniques are implemented at the database layer with triggers, stop procedures, or change logs. How do you balance this with keeping key business logic in the application layer? When do you think it's a good idea to rely on this as opposed to something that lives in the application?
So look at the examples I gave for how we use CDC. If you are doing things like data replication, data warehousing, you definitely want to do CDC. We also use it for our transaction alert system because our core banking is a very central component for us, and we have a lot of transactions consummated at the core banking level, and we may want multiple clients to be able to read or see those changes. So in such a case, it might be okay to use it, but bear in mind that if you are doing a microservices architecture, sometimes it is very important to have clear partitions. You don't want certain parts of your domain to know too much about other parts of your domain, because in such a scenario, that can make it difficult, or that can create a case of tight coupling. Do you understand what I'm saying? So be careful when you are using something like CDC. You should only use it when, of course, when you have a more closely knit domain and when it's okay for parts of your system to know about these kinds of details about other parts of your system. I hope I was able to answer that question.
Sorry, muted. Yes, I think so. Thank you. That was the only question Q&A. So I think we can wrap it up here. Thank you so much for joining us. This was a really good talk, very insightful. Hope to see you again. Thank you. All right. Oh, we have one more question.
Okay.
Could you please add this to the Q&A? Then Julian, can you like go to the Q&A section and just like follow up there with the Q&As?
Where is the Q&A section? Where is the Q&A section? Yeah.
In the chat, in this.
Okay. I can see. Okay, I can see Q&A.
Yeah.
Okay.
Right. Okay. So I just add the question I saw just now as well in the chat. We have another session.
So just to...
I need to go there. Yeah.
Okay. All right. Then that's fine then. Thank you all for attending. I appreciate you all.
Thank you. All right. Bye.